one, they want us to know, is it exponential? And the answer is no. The reason it's no is 9 and x are being multiplied together. This is 9 times x. That does not make an exponential function. It makes it linear. Bless you. Problem number 2. Y equals 2 times 3 to the x. Okay? This is exponential because my exponent is the letter. So this is exponential. Then problem number 3, y equals negative 2 raised to the x power. Okay? Is this exponential? Is that x an exponent? Yeah, so exponent is a letter. So this is exponential. I told them all they had to do was just bury them deep. That wasn't deep enough. He could bury it deep in his backpack. Backpack deep. Deal? Thanks, man. All right. So remember, if you have to go to the bathroom, you need to come ask us first, and there's only one person out at a time. Got it? I'm amending my. All right. So, my friends, is there any question about these first 3? Do you feel comfortable about what it is? Is anyone stuck? You feel comfortable? So if the exponent is the letter, that means it's exponential. If the letter is not an exponent, it's not exponential. That's all you have to look at. Is the exponent the raised power? That's what you want to know. All right. Let me go back. I want to snag this here. 197. All right. So now we're moving on to the graphing, yes? So let's see. Paste. I have 5 of them total, right? Paste. Paste. Now, friends, do me this favor. This is a complex type of problem that I think you can handle, but just follow my motive. Follow what we do, and I can get you through it. It's those of you that sit there and you're so frustrated that you can't tell a time sign from an X. So let's take that off the table. So we're going to number 8. That was the next problem we did, right? All right. So f at x is equal to 1/2 raised to the x power. So you know it's exponential because of what reason? The x is the exponent, or the letter is the exponent. Is that okay so far? Is everybody on the same page there? You're all good. Now, I don't know if this is growth or decay at this point. I just know it's exponential. That's all I know. Is that okay? All right. So the next thing I'm going to do is I have my exponential thing. If I put a plus 0 at the end, does that change anything about the equation? No. Okay, that is going to be called the horizontal asymptote, which is right here. Now we're going to see today it's going to move up or down, but this, because I can add that, makes a horizontal asymptote. Okay? Remember, an asymptote is something that we cannot cross. Okay? We can come real close to it, but we don't cross it. Okay? Friends, is there anything that I have up there? Like if I were to say, all right, problem number 1, is it exponential? You could tell me if it's exponential. Problem number 2, can you tell me about the horizontal asymptote? Can you answer those 2 questions right there, do you think? Give me an honest opinion. Can you, listen, you're good? Is everyone good? We feel all right? All right. The next thing I'm going to do is I'm going to select 2 points. I'm going to select 0, comma something, and then I'm going to do 1, comma something. Now, certainly those are going to change in other classes, but for right now, we're going to plug 0 in, and we're going to plug 1 in for x. Okay, so the first problem, I get 1/2 raised to the 0 power. What is 1/2 to the 0 power? 1. So 0, 1 goes right here. Okay? Let's change colors. Go to blue. Now I'm going to plug 1 in. I get 1/2 raised to the first power. What's 1/2 to the first power? Just 1/2. So 1, 1/2. Now, I'm not going to draw the picture in yet, but do you feel comfortable with everything I've got up there so far? Okay, and again, I'm plugging 0 in and I'm plugging 1 in. I'm only identifying 2 points. Now, I realize 2 points define a straight line, but for this case, we have to realize that this is going to have a curved picture like this. Okay? That's what it looks like. Now, friends, am I exactly right on the left side of it where it's going up? No, but I'm probably kind of sort of close. I have the general shape. Okay. Now, my friends, is this growth or decay? Now, before you answer, as I go to the right, am I going away from the asymptote or am I going to the asymptote? I'm going to, right? So is it growth or decay? This is decay.
Also, another way to see it, you see how we're going from a huge area to all of a sudden we're going right into this tiny little area. Decay is like that idea. Going from something big, going to something small. Growth is the opposite. You start small and you grow out. Okay?
Yes.
Like when you actually decay, you go big to small. When you grow, you go from small to big.
All right. Friends, what is the domain of each and every one of these? Giddy up. Don't miss that kind of question. Okay? Friends, are we okay so far on the whole thing? Okay. We're going to get cutesy. You bought yourself a balloon. You got yourself a balloon at the store. Okay, it's a heart shape. Aw, that's so nice.
Because you love yourself.
Okay, so this balloon is going to float up. Okay, do you agree this balloon's floating up? So right here, can the balloon, let's say the balloon does have eyes. I know it doesn't, but let's say it does. Can the balloon see the graph now? Can it see the blue graph? And the balloon's going to keep going up. Can the balloon keep seeing the blue graph as they go up? Okay, so my range starts at 0 and goes to infinity. Okay? So think about this balloon. Oops, not as a green line. Think of this balloon. This balloon goes up and down. It's on your string. Like, think of this. Can it see the graph yet? Now it can. And I know that a balloon doesn't have eyes, but let's just pretend. Nope. So, friends. So, Jack, this is the exact thing you can do. You know this right here? That's always going to be right here, or it'll be on the other side. It's either a negative infinity up to that or that. So notice I have plus 0. We're going to have something that are going to have like plus 3 and plus 4. So that's always going to be what part of the range is. So these two go together for the most part. That end part becomes part of the range. It doesn't have to be the first number. It could be the second, depending upon how the graph goes.
So I would highlight that.
The red dot is part of the graph. The graph itself still goes to the right and approaches the asymptote. Yeah, and it's a round bracket because remember, a round bracket means you come close but you don't touch. Today, yeah, we're going to show how the asymptote moves up or down. And it's pretty simple, I think. Okay? So something I want to kind of show real quick. I'll just show it on Desmos because I know how to use Desmos pretty well. And if you take me for statistics, you always get to use Desmos in statistics. Senior year, there's a plug. All right, so y equals 2 raised to the x. Okay? Actually, what was the problem we did? We had 1/2, right? So let's do y equals 1/2 raised to the, oops, raised to the second. Oops, I did something wrong. Oh, I got too many parentheses in there. It should be to the x. Stir up, figure this out. All right. So the blue line is basically our thing. So we had a point at, let me get rid of the red one. We had a point here. That's one of our points, right? And then this point right here, is that another point we had? Now watch what I'm going to do. Watch the y value. The y value is the second value. So I'm going to move this over this way. So what's going on with that decimal? Is it getting a bigger decimal or is it getting to be real small? Real small. And as I travel, I mean, look at how small that is. I'm at 0.01 at that point, only 6 over. Okay? I could move the graph and I could say, well, what's the point over here? It appears it's almost 0, but if you look at that 0, Desmos has a default. If I went into the table of commands, I'd be able to see how small it could be. In fact, if I zoom in real close right here, they had set it at 0. So friends, if that blue line was at 0, that means that blue line would be, well, look at what value it's at now. And as I go, it's getting smaller and smaller. And it's taking longer to get smaller because I zoomed in so much. Okay? That's basically what's going on with exponential functions. Okay? So let's look at number 9. Is that okay?
Yeah.
So first thing, is number 9, is it exponential function just by looking at it? Is this an exponential function just looking at it? Yeah. Okay. Is there anything on the end? No, but we're going to add a 0. What does that 0 represent, my friends? Part of the range, but what else does it go with? Asymptote. Yeah. Here's my asymptote. Okay. So that's my asymptote. So now I'm going to plug, I don't know if this is growth or decay just by looking at it, but I'm going to plug 0, comma, and I'm going to plug 1, comma into our equation. Okay? So let's take this one as blue. So I'm going to go negative 1/3 raised to the 0 power. What is 1/3 to the 0? 1. And then I have the negative outside, so it becomes a -1. So 0, -1 is right here. Is that okay? Do you see how I made that negative? Gotta be cautious on those. Now I'm going to plug 1 in, so I get negative 1/3 to the first. 1/3 to the first is just 1/3, so I get negative 1/3. 1 comma 1/3, that's like right here. So this is what it looks like. Is this growth or decay? It's growth. As I go to the right, it gets really close to the asymptote. So this is, what did we say? Decay. I had that in my head. It's decay. As I go to the right, it gets really close. Hey, what's the domain? Huh? It's not growth. As I go to the right, it goes to the asymptote. It's decay. As I go this way, it gets really close to that red dotted line. So it's decay. It'd go away. So growth is going to do this. As I go right, based on this board, as I go right, it does that. Decay will do this. Okay?
So again, it's like that idea of like, you start small as a kid and you grow taller, you grow bigger, right? It's like that growth. So like growth, you start small, and really actually would go this way. Start small and you get bigger, right? Decay, when you're starting to get older as an old person, you start big, but then you start to shrink. So that's how I see it.
We okay with negative, positive infinity for the domain?
Yeah.
All right, let's get our balloon. Let's get our balloon. Maybe we won't use a heart-shaped one this time. Oh, we got the star balloon this time. Yay. All right, we got the star balloon this time. So the star balloon's way down here. And it's only going to go because that red thing is like a ceiling. So that red dot's going to get up to the ceiling. Okay, so what is my range going to be? What is way down low forever? Negative infinity. What is my 0? Okay, remember, because we added 0. Oops, wrong one. I want to go here. Okay, remember, whatever we did here is going to be at one point here. Now remember, on the last graph, I had the 0 first. But on this graph, because we had to start from the bottom and move up to the ceiling, I went there. Okay? Okay, move on. Number 10. H at x, that's the same thing as f, right? 1/2 times 4 raised to the x. Okay, is it exponential? Yeah, it's raised to a letter. Can I put a +0 at the end? What is that going to be? Range and our horizontal asymptote. Okay, now I don't know if it's the top part of my range or the bottom part of the range yet, but I have to start graphing it. Okay, so I'm going to plug 0 in, and I'm going to plug 1 in. Just do the math. So I get 1/2 times 4 raised to the 0. What's 4 to the 0? 1. What's half times 1? 1/2. So 0, 1/2 is like right here. I'm going to plug 1 in. What's 4 to the first? 4. What's half of 4? So this is what this is going to look like. Growth or decay? Growth. As I go to the right, it's going away from my asymptote. Okay? What's the domain? Negative to positive. All right. Let's get our range. We'll get a balloon. And now we're going to have a, let's have, we're going to go with purplish balloon. Oops.
Isn't it if it just goes, if it's just growth, isn't it, positive infinity and then 0?
Kind of.
All right. Are we looking at the range? Is that what you're asking for?
Yeah.
All right. Ready? So we're inside the house, right? We're under the roof. The asymptote's the roof. So now we're outside. Okay. If I let my balloon go now, it's going to go from the roof line. What's my roof line as a number? 0, and it's going to go up. What's it going to go up to? Okay, so my range is 0 to infinity. Okay, it's outside the house. Again, this went along with that.
So like going to kind of look your question, so like we look at number 8 was decay, but for our range is 0 to infinity, right? Whereas number 10 is growth. We still have that range from 0 to infinity. So the biggest thing is thinking with range is that placement.
So yeah, look. So here, 0 to infinity. Here, in negative infinity to 0. Are we under the asymptote? If we're under the asymptote, we're going to have 0 or the asymptote for the second number. If we're above the asymptote, whatever the asymptote is will be the first number. Okay. All right. Ready? Number 11, yes? All right. F at x, fancy way of saying y. 3 times 2 raised to the x. Is this exponential?
Yes.
Yeah, the x is the exponent. Can I put a plus 0 at the end?
Yeah.
So that comes around here. I will use that 0 at another time as well. So let's figure this out. I'm going to plug in 0, and I'm going to plug in 1. If I plug 0 in, I get 3 times 2 raised to the 0. 2 to the 0 power is what? 2 to the 0 is what? 1. 3 times 1 is? So 0, 3, it's up here. I'm going to plug 1 in, so I get 3 times 2 to the first. What's 2 to the first? 2. So I get 3 times 2, which is 6. So 1 comma 6. 1, 2, 3, 4, 5, 6. Friends, growth or decay? Growth. As I'm going to the right, it's going away from the asymptote. Okay, domain? Negative, positive. Okay, my range. Good. 0 to what? Perfect. I started at the asymptote and went up. I didn't start below the asymptote and come up to it.
So on all the isotopes that are well, not isotopes, but on all the ones that are increasing, is the range domain always going to be the same?
The domain is always going to be the same. We're going to change our range a little bit later in today's lesson. Okay?
Well, and a good example of that is like, if you look again at like number 8, number 10, those are good indication that both the ranges start with 0, but one of them is growth, one of them is decay, just depending on where that graph placement is. That's what's going to affect the range.
All right, plus 0, yes?
But good questions.
All right, 0 comma blank and 1 comma blank. All right, negative 2 times 4 to the 0. 4 to the 0 is? 1. Negative 2 times 1? Negative 2. 0, negative 2 is right here. Agree? Plug 1 in. Negative 2 times 4 to the first. 4 to the first is what? 4. Negative 2 times 4 is negative 8. 3, 4, 5, 6, 7, 8. Growth or decay? As I go to the right, is it going away from the asymptote or going to it? So this is growth. Domain? Range? Yeah, say it. There you go. That's it. Good job. Okay, Stone. Will you walk around and check off if they got their homework done?
Yep.
And make fun of whoever didn't even write down what we wrote down?
Always.
Yeah. All right, my friends. I'm on page 199. Page 199, you with me? Ready? Set. Dude, give me 10 minutes. You wait? All right. Cross your legs. All right. Here we go. So, taking a look at the first one. Friends. What should I put at the end of this? What should I put at the end of this?
0.
Yeah, thank you. So that's my asymptote. Good so far? This is exponential because it's raised. All right, so now I'm going to plug 0 in. So I get 1/2 times 2 to the 0. 2 to the 0 is? 2 to the 0 is? 1. 1/2 times 1 is 1/2. So that's like right there. Agree? All right, plug in 1 in. So 1/2 times 2 to the first. 2 to the first is 2. What's half of 2? 1. Sure.
Sorry, I made a couple of them look back and forth.
Oh, I'm sorry. It's fine.
Everyone had their homework done. Get
Dude,
it
best class ever. Don't tell 5th period. They'll be jealous.
What, who's in your 5th period math class?
People.
Is Ada in it?
Yeah.
Okay. Then I'll tell Ada.
All right. Morgan, you caught up with me now?
Yeah.
Okay. All right, so friends, this is like kind of slow, but then does this. All right. Growth. Good. Domain. Good. Nuri. Range.
0,
There you go. Good. All right, let's do this one. Can I go +0 at the end? There's my asymptote. Agree? All right, we're going to plug 0 in. So -2 times 3 to the 0. 3 to the 0 is? 1. 1 times -2? It's down there. Agree? Plug 1 in. 3 to the first is what? 3. 3 times -2? Down here. Friends, growth or decay? Growth. Domain? Negative to positive infinity. Range? Nuri. Yeah, baby. Feeling all right about that? Cool. All right. So as soon as you get done writing something down, turn to your neighbor and let him know that there's going to be something really weird that we're going to do on the board. Which board?
That board.
Either of the two.
Either of the two? We ready? Does anyone need more time? Anna, you good?
Yeah.
Something weird's going to happen here in a sec. Okay?
Get ready.
We ready?
Oh.
Okay. So I'm not sure if this will be on the test or not, but I still wanted to go over it. It says the graph represents bacteria population Y after X days. Write an exponential function that represents the population. Find the population after 12 hours and after 5 days. Okay. So, friends, our general equation is this. Okay. A times B raised to the X plus C. Now, friends, my C value for this is 0. Okay, because it looks like my asymptote's right down here, right? So that's going to become a 0. Okay, we good so far? Okay. Hey, is this growth or decay? Growth. As I go to the right, it goes up. All right. So, friends, now what you're going to have to do is you're going to have to pick 2 of those points. Now, I don't think picking the point 4, 768 is a good idea. I would say I would pick the point 0, 3, and I'd pick the point 1, 12. You still with me? Everyone feel comfortable with what we got so far? Basically, the 0, 3 means that we started out with the day. Very first day is like, look, we have 3 bacteria. 1 day later, we have 12 bacteria. All right. So, because this is plus 0, this is the only portion of the equation I'm going to deal with, okay? This is going to be some critical thinking. Ready? First off, is that an X and a Y value? Did I put that the correct way? Everyone feel comfortable with that? Friends, in the circled equation, y equals a times b raised to the x, is there an x and a y? All right, ready? So I'm going to take the equation above. I'm going to go 3 equals a times b raised to the 0. Take a look. Did I do that correctly? Friends, what is b to the 0? 1. So if this is 1, this is 1. A times 1 is a. So I find that a is equal to 3. You still with me? So I've solved one of my unknown variables. Okay. So friends, this 3 right here is going to go in for right here when I use this equation again. Does that seem okay? Now I'm going to use my other point, 1 comma 12. Friends, is this an x and a y value in that order? Okay, so I know I have y equals, it is a times b to the x. What did I find a to be? What is a? What is a? 3. What is y? 12. What is b? We don't know. What is b raised to? The first. So this is the same thing as 3b equals 12. So b has to equal what? Okay. That is going to go here. So ready? The exponential function that goes along with this. Y equals, what did I say a equals? Times, what did I say b is equal to?
4.
And it's raised to the x. This is the exponential function of this. Whoa. I don't know if that's going to be on the test. Actually, what I should do is I should make 2 of those problems on the test and then the rest everything else. And I'll say, do you want just do 2 problems like this or do you want the whole test? All right. We doing okay, friends? All right, friends, I need you to tell your neighbor that this next concept will make sense and pay attention. Okay. You ready?
Yeah.
Hey, what appears to be different about this problem right now? There's not a plus 0 we put it on the end. There's a plus what already there? 3. 1, 2, 3. Friends, that green line right there is my horizontal asymptote. Do you see how it went up 3? If it was minus 3, what would it have done? It would have gone down 3. All right. Let me get rid of that. All right. So friends, I think we could do this. I have full faith. So I'm going to plug in 0 first. So I get y equals 2 raised to the 0 plus 3. What's 2 to the 0?
1.
What's 1 plus 3? 0, 4 is right here. That okay? What's another number I like plugging in?
1.
Plug in 1. Ready? Y equals 2 to the first power plus 3. What's 2 to the first? 2. 2 plus 3 is? Good. 1 comma 5. 1, 2, 3, 4, 5. Growth or decay? Growth. As I go to the right, it's going away from the asymptote. Domain? Good. All right, Nuri, you're going to get this. Not going to use 0 anymore. I don't have a plus 0 up there. What do I have? 3 to infinity. Good job. You see how that range just changed? Ooh, baby. That's it. All right, last problem of the day. You ready for this? Excuse me. Ready? Here we go. Friends, what do you think the asymptote should be?
-5.
Yeah, baby. That's my asymptote. So 1, 2, 3, 4, 5. That pink line's my asymptote. You still with me? All right. I'm going to plug in 0. So I'm going to get y equals 3 raised to the 0 minus 5. What's 3 to the 0? 1. What's 1 minus 5?
4.
Oh, I put it up there already. Negative 4. All right, so 0, negative 4. 1, 2, 3, 4. It's right there. All right, let's plug a 1 in. So I get y equals, what's 3 to the first?
3.
3. What's 3 minus 5?
2.
Negative 2. So I get 1, negative 2. Growth or decay?
Okay.
As I go to the right, is it going to the...
Grow.
This is growth. Domain.
-5.
Range. You got this, Nuri.
-5.
Yeah, baby.
and 6.
There you go. Dude, proud of you. All right. The opportunity for tonight. Opportunity for tonight is going to be page 201, 202. We're going to do 1 through 3, 8 through 12. And then I want you to try 15. Deal?